Okay, we're going to be doing what's called investigating roots. And we're going to be using a formula known as the discriminant. Okay, so I've written it as D here, but normally there's nothing on the other side of this. This is known as the discriminant, and we use this to figure out how many, I think it is A-N-T, discriminant.
So you got the eyes.
I got it. Okay, so it is used to tell us how many roots or x-intercepts are in an equation. So we have an equation here which we're going to address after. But this formula here is known as our discriminant, okay? And it's actually taken directly out of the quadratic formula right here. The reason it's taken out of there is it will tell us or help us figure out if our quadratic has no roots, one root, or two roots. And I'll show you a quick example of each. We'll do the two no roots in blue. So a no root would be something like this, where the vertex is above the x-axis, facing up, or below, facing down. And if you notice, there are no x-intercepts. Our blue one here, this would be one x-intercept, where the vertex is on the x-axis, and it can be facing up or down. And the last one, which we'll do in purple, will have two x-intercepts, where the vertex is below the x-axis facing up, or above and facing down. Okay? So each of these, this is two roots, one root, and zero roots. Okay. So these are our three options for answers. You either have quadratics that have no x-intercepts, one x-intercept, or two x-intercepts. There's really nothing else along that spectrum. Now the reason we use this part of the formula, and I'm going to relate it back to this, is if our discriminant is larger than 0, okay? So if b squared minus 4ac is larger than 0, which is also known as a positive value, we will have two roots, okay? If our discriminant is equal to 0, so b squared minus 4ac is equal to 0, known as just 0, we will have one root. And if our discriminant is less than 0, which is known as a negative value, okay, we will have zero roots, or zero x-intercepts in this specific case. Okay? So, this is the general information we need. We're going to go up to our equation here. Now, just like the quadratic formula, we needed our equation to be in standard form in order to plug things in. So this is not in standard form. The very first step for us will be turning it into standard form. And I'm briefly going to talk about something else before we start that. The reason when this is greater than 0, we'll have two roots. Okay? So let's think of a number greater than 0. Who can give me an example? 1. Perfect. So if we were to find the square root of 1, we would have two answers. We'll have a positive 1 and a negative 1, which will give us two x-intercepts in the end. Hence why if this is larger than 1, we get two roots. If our square root is a 0, whether we add or subtract 0, it's going to make no difference. Okay? And we're going to end up with two answers that will be identical. In other words, we'll really only have one answer in that case. And finally, what would be a value where our 0 or our discriminant is less than 0? Negative 1. Can I find the root of negative 1? No. So in other words, there are no roots. I cannot find an x-intercept in that case. So specifically, because we're trying to find an x-intercept, we need to put this in the standard form and set it equal to 0. So we're going to rewrite it at the bottom here. Actually, what I'll do is just copy and paste it instead of rewriting it. Okay.
So with the equation, what we're trying to do is
What we're going to do is we're going to use it to figure out how many x-intercepts are in this question. We use quadratic formula to find out what the x-intercepts are, but this can essentially tell us how many there are and whether it's worth going into the quadratic formula. So remember we said we need to put it into standard form first. Well, to put this in standard form, I'm going to move 8 and negative 2x to the other side. What will be left on the left side of the equation? 0. When I move those two, we'll have nothing left. So we'll have 5x squared. This will become positive, plus 8x, minus 4, and that 8 will become negative. Then we collect our like terms. So I'm just going to quickly underline what are like terms. We have 0 is equal to 7x squared plus 8x minus 12. Good. Now we have an A value, a B value. What is it, Jerry? And a C value. No. Okay, so we're going to put this into the discriminant, these values into our actual formula to figure out what it's going to be equal to. So we'll say our D is equal to, and we know it was B squared minus 4AC. Well, in this case, B is the value of 8. Our A in this case is what? 7. And our C is not just 12, but negative 12. Great. Okay. 8 squared will give us 64. Now, when you're multiplying this, think of this like it is a negative 4. So what is negative 4 times positive 7? Negative 28. Good. We'll get a calculator for the next step. Negative 28 multiplied by negative 12. Positive 336. Okay. And when we finally put this together, what is that? It's 0, a 0. Oh, is that perfectly 400? Oh, nice. Okay. More importantly, the actual value of this is not the important part for us right now. What is this? Is this above 0, below 0, or 0?
0.
It's above. It's positive. So if it's positive, how many roots or x-intercepts do we have? That's right.
2.
There are 2 roots to this question. So we're always going to put our stuff into standard form. And then from there, we're going to solve our discriminant to help us find roots. So I'm going to pause for a second and make up 2 other questions. So, first one we have, our discriminant. We're going to plug our values in. We're going to figure out how many roots there are. So exact same idea. Our B value is a negative 8. So we'll have negative 8 squared minus 4. A happens to be 4. And C happens to be 4. 8 squared will give us 64. And 4 cubed, or 4 times itself 3 times, anyone know?
64.
Excellent. So when we subtract those values, we get 0. How many roots are there?
1.
That means there is 1 root. In other words, the vertex is directly on the x-axis. Okay. And finally, our B in this case is negative 2 squared minus 4. Our A is negative 8, and our C is negative 7. 2 squared is positive 4. 3 negatives times each other will give us a negative value. 8 times 7 is 56. Times 4 is 224. And when we subtract our 4, we'll get negative 220, which means how many roots are in this question?
0.
That's right. There are 0 roots to this question.